All right, let's go ahead and finish off these exponential graphs. So now let's take them where they're not just going to be one of these. We're going to start doing other stuff to them. So now let's like add in a number at the end of it. So we're changing that b value because in the last four examples it was 0. So now we're going to switch it to something else. So now your horizontal asymptote is right at 3. And the negative in front of the x means it's going to be doing something like this. So it's going to be flat on the left and shooting down on the right. So we need to make sure that it's hitting the y-axis at the right place, because otherwise it's going to be off. So you're still going to plug in 0 for x. And so if you do, that would be negative 2 to the 0 plus 3. And then just don't get working too fast, because I see it all the time. They'll go negative 2 to the 0 is 0, or negative 2 to the 0 is negative 2, which in reality it's really negative 1. To give you a total of 2. So the y-intercept is really there. Okay. So it's just this curve flipped upside down. So something like that. So that's all I'm looking for. Do you have the right horizontal asymptote? Do you have the right shape? And do you have the right y-intercept? And the domain and range. So the domain is still all reals. Range this time is negative infinity, but it doesn't stop at 0. It keeps going all the way up to, but not including the 3. Let's try this one. So where would your horizontal asymptote be, for example, f? And if we were actually in class, everybody would say negative 4, and I would say, yes, you got it. Yeah. The base has a positive in front of it, the x has a positive in front of it, so that's just like the parent graph. We've just kind of like shifted it down. And there is a shift to the left of negative 1, but for exponential functions, you don't really see that in your sketch. So if it's shifting left or right, don't worry too much about it. If we were using graph paper, then you would see it, but on sketches, you don't. Okay, so if you plugged in 0 for x, 0 plus 1 is 1, 3 to the 1 is 3, 3 minus 4 is negative 1. Domain all reals, and then your range, negative 4 to infinity. Okay, part G, you have a horizontal asymptote right at the 1. You have a positive sitting out in front of the 5, it's a positive 2. And you have a negative sitting in front of the x, so that's going to create the situation like example B. So just like that. The 2 just stretches the graph out, but again, it's a sketch, you don't really see it. If you were using Desmos or graphing calculator, then you would. But for sketches, you don't. So plug in 0 for x, that'd be 5 to the first, or 5. 5 times 2 is 10, 10 plus 1 is 11. And with these as well, like, try not to do things too much to scale. So we don't have to be that accurate. Just accurate with your data. All right, and then the last one, we have a horizontal asymptote negative 1. And the 7 has a negative in front of it, and the x also has a negative in front of it. So that's going to look like this graph right here. It's been flipped upside down and over the y-axis. We just have to make sure we're putting it in the right spot, in the right y value. So we know it's going to go like that. So if x is 0, we're going to get negative 49 minus 1, or negative 50. Still all reals for the domain, and the range would be negative infinity to negative 1. Okay, so that's going to do it for the graphs. For the most part, we'll come back and visit it in the next video, I think, because there's one special case that we haven't talked about yet. But let's stop it here, because in the next video, we'll go ahead and try to solve some equations with these types of guys.